Hello students, welcome back to Vedantu's NCERT Solutions for class 11 and 12. I am your chemistry master teacher, Ankita. We are going to discuss the fifth question from D and F block elements. What may be the stable oxidation state of the transition element with the following d electron configuration? They have given us the d electronic configuration. We should understand that it will have s electrons as well. 4s will be there. So in the ground state of their atoms, 3d3, 3d5, 3d8 and 3d4. So let's see the electronic configuration first. They have given us 3d electronic configuration in the ground state, not in their oxidation states. Okay, so if we talk about 3d, which is that first one, 3d3. So vanadium, right? It is vanadium's ground state configuration. So it is 3d3 4s2. 3d3 4s2. This is the actual electronic configuration. We have argon as well. Argon followed by 3d3 and 4s2. So what is the stable electronic configuration here? It can show +2 oxidation state if you remove 2 electrons from s orbital, and it can show +4 oxidation state. It can show +5 oxidation state as well. Okay, so it can show +3 oxidation state as well. And then we have 3d5. So 3d5, so whose electronic configuration is it? 3d5. So it can be chromium. Okay, it is chromium. So it has 3d5 4s1. Argon 3d5 4s1. So what will be the stable electronic configuration in case of chromium? So it's going to be +2. It is going to show +3 oxidation state, +4, +5 as well as +6. So +6 when we remove all the electrons from 4s and 3d orbital. 3d5 is not only shown by chromium, but manganese also shows 3d5 electronic configuration. Manganese. Argon 3d5 4s2. 3d5 4s2. So manganese shows oxidation states from +2 to +7. +2 to +7. And then we have the configuration 3d8. 3d8. So 3d8 is shown by nickel. It is shown by nickel. Okay. So yes, it is shown by nickel, and the electronic configuration is 3d8 4s2. 3d8 4s2. So the electronic configurations, oxidation states that are shown are +2 and +3 as well as +4. So +2 and +3 and +4. These are the oxidation states that are shown by nickel. And then we have 3d4 ground state configuration. Actually 3d4 is not shown by any of the metals, because when it comes to chromium, it shows 3d5 4s1 configuration. Okay, why? Because 3d5, it is half filled. It is half filled. Rather than showing 3d4 and 4s2, it shows 3d5 4s1 electronic configuration, because half filled and completely filled orbitals are more stable. So 3d4, there is no 3d4 configuration. 3d4 configuration in the ground state. 3d4 is not shown by any of the transition 3d4 is not shown by any of the transition metals. This oxidation state is not shown. So when it comes to 3d8, so along with nickel, so 3d8 is shown by cobalt as well. Let me move on here. 3d8 is shown by cobalt as well. So what is the electronic configuration here? It shows 3d8 4s1. It shows 3d8 4s1. So it shows the stable oxidation states of +2 as well as +3. Okay. So yes, the stable oxidation states of transition element with a d electronic configuration 3d3, 3d5, 3d8 and 3d4. 3d4 is not shown by any of the metals, because 3d5 is more stable. Rather, being 3d4 4s2, chromium is going to attain Chromium is going to attain 3d5 4s1 electronic configuration because 3d5 is half filled here. Half filled and completely filled orbitals are extremely stable.